Around 252 million years ago, the Earth experienced a cataclysm unlike any seen before. In what is now Siberia, massive volcanic eruptions began. These eruptions were not the typical cone-shaped volcanoes we often imagine. Instead, imagine fissures in the Earth's crust, stretching for miles, spewing out lava in unimaginable quantities. This event, lasting for hundreds of thousands of years, formed the Siberian Traps. The Traps are a vast region of volcanic rock, a testament to the sheer scale of the eruptions. The immediate impact on the surrounding environment was devastating. Lava flows incinerated everything in their path. Forests were turned to ash, and the air itself became thick with toxic gases. But the true horror of the Siberian Traps eruptions lay in their long-term effects on the global climate. Massive amounts of carbon dioxide, a potent greenhouse gas, were released into the atmosphere. This caused a rapid increase in global temperatures, a phenomenon we now call global warming. The oceans, absorbing much of this heat and carbon dioxide, became more acidic. This combination of factors created a hostile environment for life on Earth, both on land and in the seas. The Siberian Traps eruptions were not a single event, but rather a prolonged period of volcanic activity. This relentless outpouring of lava and gases had a devastating cumulative effect on the planet. It was the beginning of the end for most life on Earth. The Great Dying was Earth's most severe known extinction event. It marked the end of the Permian period and the beginning of the Triassic, a transition forever etched in the fossil record. Triggered by the Siberian Traps eruptions, the consequences of this volcanic activity were felt across the globe. On land, the rising temperatures created extreme weather patterns. Droughts became more frequent and severe. Wildfires raged across continents, further altering landscapes and releasing more carbon dioxide into the atmosphere. The once thriving ecosystems of the Permian began to collapse. In the oceans, the effects were even more profound. The increasing acidity of the water made it difficult for marine organisms, particularly those with shells or skeletons made of calcium carbonate, to survive. Coral reefs, vibrant underwater ecosystems, were decimated. The food chain collapsed as species after species succumbed to the changing environment. By the end of the Permian, an estimated 90% of all marine species and 70% of terrestrial vertebrate species had vanished. The world was a shadow of its former self, a testament to the destructive power of unchecked climate change. The Great Dying stands as a stark reminder of the interconnectedness of life on Earth and the devastating consequences of environmental catastrophe. In the aftermath of the Great Dying, life on Earth faced a daunting challenge: recovery. The planet was a vastly different place, with a hotter climate and altered landscapes. Yet life, as it has done time and again throughout Earth's history, found a way to persevere. Among the survivors were a group of plants that would shape the post-extinction world, the conifers. These cone-bearing trees, with their waxy needles and drought-resistant features, were well suited to the drier, harsher conditions of the early Triassic. They spread across the continents, their seeds carried by the wind, slowly reclaiming the barren landscapes. The rise of conifers had a profound impact on the evolution of life on land. Their tough, needle-like leaves provided a new food source for herbivores. Their tall trunks and spreading branches created new habitats for a variety of animals. The world was slowly beginning to heal, with conifers playing a crucial role in rebuilding ecosystems. The recovery from the Great Dying was a slow and gradual process. It took millions of years for life to fully diversify and reclaim its place on Earth. But from the ashes of this catastrophic event, a new world emerged. A world shaped by the survivors and the lessons of extinction. As the planet recovered from the Great Dying, a new cast of characters emerged on the evolutionary stage. Among them were two groups of reptiles that would play pivotal roles in the history of life: the synapsids and the archosaurs. The synapsids, characterized by a single opening in the skull behind each eye, were the ancestors of mammals. They were a diverse group, ranging from small, rodent-like creatures to larger, sail-backed predators. Synapsids thrived in the early Triassic, their warm-blooded metabolism and diverse feeding habits allowing them to adapt to a variety of environments. The archosaurs, meaning ruling reptiles, were another successful group of reptiles. They possessed a distinctive skull structure with two openings behind each eye. This group included the ancestors of crocodiles, pterosaurs, flying reptiles, and dinosaurs. Archosaurs were initially smaller and less diverse than synapsids, but their evolutionary journey was just beginning. The early Triassic was a time of experimentation and diversification for reptiles. Synapsids and archosaurs, along with other reptile groups, competed for resources and explored new ecological niches. The stage was set for an evolutionary showdown that would determine the course of life on Earth for millions of years to come.